Okay, hello students. So in this video, we're going to look at a question that comes from Additional Mathematics, paper 1, question 6. The question reads, prove the identity. Sine theta over 1 plus cosine theta plus 1 plus cosine theta divided by sine theta is identical to 2 cosec theta. So this is the cosec theta. So it's like this, sine theta divided by 1 plus cosine theta plus 1 plus cosine theta over sine theta. This is identical to 2 cosecant theta. So by proving the identity, we have to show that this side, the left hand side, should be equal to the right hand side, or showing that the right hand side is equal to the left hand side. So what we need to do is we can break down one of the sides. When we break down one of the sides, it has to turn into the other side. So before we prove this identity, you need to be familiar with some basic trigonometric identities, such as tan theta is simply sine theta over cosine theta. Cot theta is simply cos theta over sine theta. And one of the Pythagorean identities, which is sine squared theta plus cos squared theta identical to 1. We can build a lot from here. What else can we have? 1 plus tan squared theta. This is identical to sec squared theta. 1 plus cot squared theta. This is identical to cosec squared theta. Okay, so let's begin. So I want to show that this side is equal to this side, or the other way around. What I recommend you to do is I recommend that you take the side which looks to be more complicated. In this case, the left hand side. So taking the left hand side, so we need to break down the left hand side so that it turns into the right hand side. So we have sine theta divided by 1 plus cosine theta plus 1 plus cosine theta divided by sine theta. So what we're going to do here, we can just look for a common denominator. We have this fraction which we can deal with. So 1 plus cosine theta and sine theta, these are our common denominators. So 1 plus cosine theta into this expression, it will go there, sine theta times. So sine theta multiplied by this, that will give us sine squared theta. Then sine theta into this will be left with this expression. So this multiplied by that, we're going to have 1 plus cosine theta multiplied by 1 plus cosine theta. So this will reduce to sine squared theta. Take note, this is repeated. So instead of having 1 plus cosine theta, I can just have 1 plus cosine theta squared. Then everything divided by 1 plus cosine theta multiplied by sine theta. So we shall have, we can expand this. So we're going to have sine squared theta, 1 squared, simply 1, cosine theta squared, that is simply cos squared theta. Then 1 times cosine theta, that is cosine theta multiplied by 2. We're going to have 2 cosine theta. Or if you want, you can just take your time and expand this. It will still give you the same thing. So over 1 plus cosine theta multiplied by sine theta. Then I can collect something here. I can have these guys, sine squared theta plus cos squared theta plus 1 plus 2 cosine theta over 1 plus cosine theta multiplied by sine theta. Then we want to make sure that the entire expression ends up being 2 cosine theta, cosec theta. Cosec theta is simply the inverse of sine theta. When we say cosec theta, what we mean is 1 over sine theta. So everything must end up being 1 over sine theta. So what can we do? So we have sine squared theta here, and I have a cos squared theta here. So what I can just do, I can break this. So remember, we had something like this: sine squared theta plus cos squared theta. This was identical to 1. So from here, we can come up with many of them. We can make sine squared theta the subject of the formula. We can have sine squared theta identical to 1 minus cos squared theta. So where there's sine squared theta, I can have this. So here, we can have 1 minus cos squared theta. Then we have this, that is plus cos squared theta. So this sine squared theta has been replaced by 1 minus cos squared theta. So we have 1 minus cos squared theta, then plus cos squared theta, then plus 1, then plus 2 cosine theta. Then everything is divided by 1 plus cosine theta multiplied by sine theta. These will go. We have 1 plus 1, which is 2. So we have 2 plus 2 cosine theta. Everything divided by 1 plus cosine theta multiplied by sine theta. From the numerator, I can see that I have a factor of 2. I can factorize. So 2 out, I'll be left with 1 there, plus cosine theta. Here we have 1 plus cosine theta multiplied by sine theta. We can clearly see that the 1 plus cosine theta and the 1 plus cosine theta will go. We'll be left with, so we have 2 plus cosine theta here. Okay, then 1 plus cosine theta. Remember, these disappeared because of the replacement that took place. So we had 1 plus 1, which is 2. Then we have 2 cosine theta, which is here. So here we can see that 2 is a factor, so 2 is out. So inside there we have 1 plus cosine theta. But in the denominator we also have a 1 plus cosine theta factor. So these will go. We'll be left with 2 divided by sine theta. Now, I can write this as 2 multiplied by 1 over sine theta. It's the same as 2 sine theta. Then we know that 1 over sine theta is the same as cosec theta. So this will just reduce to 2 multiplied by cosec theta. And therefore, left hand side is equal to right hand side. Hence, proved. That's all. Thank you so much.